I will now come to part 2 of my presentation. So the definition of this was what the Annex 80 is, what is our objective, what we are doing, and when. And now this is the first major achievement which we had in the Annex 80 is the definition of resilient cooling of buildings, and a short overview of indicators, how to assess this resilience. And the findings I'm showing here are based on 2 papers from my colleagues, Wendy Miller from Australia, from Queensland, Technical University of Queensland, and Shady Atta from University of Liège. The main authors, of course, this is a body of work with contributions from a lot of other experts too. So when we talk about resilience in terms of cooling, then we have to define boundaries, because resilience is not a common concept in the built environment. It comes more from a disaster risk assessment, and the scopes are usually much bigger. So first we had to define the boundaries. What are the boundaries when we talk about resilience? And what you can see here, we stop we rest within the building. So we won't look at urban districts, cities, or even other scales. We are only talking about the building. Then we talk at a range of about 100 years, so until the end of the century, 2100. And we only talk about heat waves and power outages. So of course, one disruptive event which we just are going through is like the pandemic. So it's more like European considered with an air pollution problem in indoor spaces, but we're not looking at this. So we only look at heat waves and power outages. So and why resilience? So why is this such an important issue? It's just a short diagram, which you probably know. We know that the climate is changing and that we will in the future experience more severe and longer heat waves. This is just a matter of the climate shift, and in connection to this, the risk of power outages due to peak load demands and other effects. And when we look into concepts of resilience, as I already said, it's a fairly new concept to the built environment, but in other disciplines, it is already there. So, for instance, in the Sendai framework from the United Nations, disaster risk reduction, and I will we don't have to look at this in detail, but to give you an idea is like first to understand the risk, and when you think and when we keep our building in mind, so what's the risk for a building? Yeah, then strengthen the governance to manage the risk. So this is also very important. Invest in risk reduction practices for resilience. So what could that be in the building? Yeah, just think about some things which you have in mind, and then enhance disaster preparedness and build back better. So this is also very important concept of resilience, is this build back better, so that the rebound, so when the building bounces back. And in terms of buildings, when we think about buildings, so we have again these 4 phases. You know, we have a vulnerability, so some buildings are more vulnerable, some are less vulnerable. Then some buildings have a higher resistance or lesser resistance to some overheating exposure or severity. Then what is very important is the robustness. So when a disruptive event happens, how robust is the building? This is really one key concept of this. And then from this robustness, the recoverability. So when the building bounces back, these are the 4 major phases, which you can see here also in this graph. So when we design a building, we usually design it for the like normal climates. So then we have some events, and the building is resistant to these events and bounces back. Then we have a bigger disruptive event, like a major heat wave. And then what we see here is like we enter into the robustness when the building cannot maintain stable indoor climatic conditions anymore. It overheats, and then it comes to a failure. So what we see here, we have the critical thermal conditions, minimal thermal conditions, design thermal conditions. So this is very important in order to define resilience, to have this disruptive event. And eventually, the building then can recover and come back to the designed thermal conditions. And then we could speak of a resilient building. So very important are these, what is written down here. So it's kind of the key parameters which are important to resilience. So this is first the thermal conditions, the weather, and of course the disruptive events, as I talked before. For the thermal conditions, we decided to stay with existing standards, of course. So the ISO 1772 part 1 and 2. So the PPD, PMV, and adaptive model. And then with the limitations of this thermal model, we also discussed that maybe in a short-term event, we could decrease the building category and allow like higher indoor temperatures or higher PMV values. For the future weather, I won't go into detail here. We have the next webinar will be on this. So we derived or generated future weather data to assess our technologies in this future weather data, weather scenarios. So we have several cities here, which we generated weather files for. But this will, as I already said, be in the webinar number 2. And then just disruptive events such as heat waves, which we then derived from this future weather files from the 2050s and 2100s, which we also saw that the number of heat waves and also the duration increases, which leads to another very high heat stress or stress strain on our buildings. And this is already the end of my introduction. I will just conclude here that we then defined categories of KPIs. I won't go into detail here because my colleague Mohamed Hamdi and Abdelaziz, they will talk in detail about this. But of course, there are thermal comfort metrics, and we talk about comfort and also like thermal safety, which in the event of heat waves and very severe disruptions is more important than comfort. We of course will talk about energy metrics, HVAC and grid metrics, and then specific metrics or KPIs to specific cooling technologies. As I already said, we have a long list of technologies we are assessing. So to conclude on the definition of resilience, so any definition of resilience must be based on the identification of a specific shock or disruption, in our case, a heat wave event and power outage. So designers must distinguish between the resistance and robustness. So against heat waves and power outage events. This is a very important concept. And that cooling design has an urgent requirement for future-proof buildings, as we saw that this disruptive events will increase in the near future. And that the building operation systems and the building management system will play a key role and a significant role in the adaptation strategies of our buildings and the health of our building users. and that the resilience is a process which should be addressed in integrating user experience during these shocks, and essentially to increase the emergency learnability and feed the preparedness loop. So the phase before a disruptive event happens. So this is the end of my presentation. I hope I could make some points clear to you. I'm happy to answer your questions later. And I will now hand over to Mohamed Hamdi, assistant professor at NTNU Norway, and he will talk in more detail about the specific metrics.